So today we're going to be learning the second of two methods in order to solve a linear system. So you'll remember that when we solve a linear system, and I'm hoping you can finish this sentence for me, that when we solve a linear system, what we're actually solving for, and let's just imagine that this is, these are actually perpendicular lines, but anyway, when we're solving a linear system, so let's say here is equation number 1, and then here I have equation number 2, then when I solve it, what I'm actually finding is the coordinate of the point of intersection. In other words, the ordered pair that satisfies both of those linear equations. So before we get into that today, let me just get rid of this. Before we get into that today, what I want to do is I want to start you off by presenting a couple of ideas that are going to be really important in order for you to make sense of some of the steps that we're going to be taking and for you to understand why we can take those steps. So the first idea is this. So let's just imagine that I had the equation x plus 2y equals 5. And I happen to know that the coordinate 3, 1 satisfies that equation. In other words, if I replace x with 3, if I replace x with 3 and I replace y with 1, then the left side of my equation should equal my right side. So let's just double check that. 3 plus 2 times 1 actually does give me 5, so I'm good to go. So I'm going to take that equation, and what I'm going to do is I'm going to double everything. So in other words, I'm going to double x, so that means I'm going to end up with 2x. I'm going to double my 2y, which will give me 4y. And I'm going to double my 5, which will give me 10. And I want to see, will that coordinate 3, 1 still satisfy this equation? You probably have an idea, but let's just double check. So 2 times whatever x is 3, plus 4 times whatever y is, and in this case I've designated y to be 1, and that's equal to 10. So let's just work this out. 6 plus 4, big surprise here, my left side still equals my right side. And so I could do the same thing. I could have tripled that equation, so 3x plus 6y equals 15, and that coordinate 3, 1 should still work. What is the lesson here? The lesson is that I can double, I can triple, I can half any linear equation as long as I'm doing it to every component of that linear equation. Then the same coordinates that satisfied the original equation will also satisfy the changed equation. So that is idea number 1. So the second idea is this, and so I want you to remember that this method is referred to as the method of elimination. So there's got to be some sort of elimination in there, something has to get eliminated. So I'm going to start you off with a simple algebra idea, right? So let's just say that we have an equation like x plus 4 equals 7. So I know that I can eliminate the plus 4 in this equation by simply subtracting it, right? And that's really when we move a component of an equation to the other side of the equation and change its sign, essentially that's what we're doing if it's an addition or a subtraction. So that allows me to essentially cancel out these the 4s, or eliminate them for that matter. Now by the same token, I could also say, okay, well, y minus 8 equals 10. So in this case, I would want to add in 8 to both sides in order to be able to eliminate the negative 8. So the idea of being able to combine equations in order to eliminate a variable, either by adding them or subtracting them, is going to be really important today. So our goal today, when using the elimination method, is to add or subtract equations in order to eliminate one of the variables, and that'll help us to solve for the other variable. All right, so let's do this. So I want to start out with a really simple example, and that will allow us to make sure that we are making sense of the ideas when the numbers are not complicated or the situation is not complicated. But then we'll move on to do another example that hopefully will be a little bit more involved. So first of all, notice that I've numbered the two equations, number 1 and number 2, and I think that that's really useful in kind of keeping things organized and remember what you did to which equation. But the first thing you're going to do is you're going to rewrite these equations one beneath each other. So for instance, I'm going to start off with equation number 1. I'm going to write that as 5x plus y equals 16. But what I need to do, I need to remember, is that I need to rewrite them, if possible, so as to align all of the variables. In other words, put the x's beneath the x's, put the y's beneath the y's. And so what I notice in this second equation here is this. I notice that I have my x on this side of the equation and my y on the other, so I'm going to take this plus y and move it to the other side of the equation in order to align my variables as I need to. So for example, I'm going to rewrite that equation number 2 as 4x minus y equals 2. And now again, what am I looking to see here? I'm looking to see that my x's are beneath my x's and my y's are beneath my y's, and I've got that circumstance, so I'm good to go. Now what I'm going to do is I'm going to look to see, I'm going to identify, once I've done that, if there is a variable that has the same coefficient in both equations. And so I know obviously that the x's do not, because the x has that 4 there and it has the 5. But I look at the y's here, and even though one is being added and one is being subtracted, the understood coefficient beside those x's is a 1. And so I've met the target for this second step. So now the next thing I need to do is I need to add or subtract these two equations as necessary, depending on the situation, in order to be able to eliminate one of the variables. So before I do that, I want to point out something that I see happen a lot, kids making mistakes about it. People will say, well, don't I just subtract these and then the y's will go? Well, let's take a look at that. So if I were to subtract those y's, I would be starting out with the positive 1y. Oops. And then I'm going to subtract, but then I'm subtracting negative 1y, right? So again, I've got 1y, oops, 1y here, and I'm subtracting negative 1y. But does that give me 0y? Does that eliminate the y's? No, it doesn't. It actually gives me 2y. And the goal, remember, is to eliminate one of the variables, so I haven't done that. So, but let's take a look at what happens if I add these two equations together. Let's see, we're going to add them. Then I end up with 1y, that's this guy up here, plus negative 1y, that's that guy right here. And in so doing, I end up with 0y. So it looks to me as though adding these equations was the right way to go if I wanted to eliminate my 0y. So I'm going to get rid of some of that, and then we're going to do exactly that. Now that you understand, hopefully, why it is that we have to add these two equations together as opposed to subtract. So we're going to add them together. And so now I can see, well, 5x plus 4x is going to give me 9x. 1y minus 1y, or plus negative 1y, gives me 0y, which I expected. And then 16 plus 2 gives me 18. Right? So let me clean that up. I've got 9x equals 18. So dividing both sides by 2 and isolating, I get x is equal to 18 divided by 2. So x is equal to 9. Oh, x is equal to, sorry, let me back that up a second here. My brain is working ahead of my hand. 18 divided by 9, so x is equal to 2. There we go. So now I have solved for one of my two variables. So the only thing left to do is to do exactly what we did with the substitution method, which is to choose either of the two original equations to use to solve for the other variable. In this case, the other variable is y. So I'm going to go ahead and I'm going to choose equation number 1, original equation number 1. And I'm going to sub in that x is equal to 2. So, oops. So 5x plus y is equal to 16. So 5 times 2 plus y is equal to 16. So I have 10 rather, plus y is equal to 16. Moving the 10 over, I get that y is equal to 6. So I've solved this system now. I have that my solution, therefore the solution is 2, 6. So that was a nice simple elimination question. What I want you to do is I want you to try an example that I'm going to put up in just 1 second. All right, so here is a question that I would like you to try using the elimination method. Now, I know that when you look at this, you can probably see that it could easily be solved using the substitution method. However, there will be questions where you will be specifically asked to use the elimination method because we're evaluating that particular skill. And so we want you to be able to know how to do that. So please solve this system by using the elimination method and by pausing the video, and then we'll come back and figure it out together. All right, so I'm going to go ahead and start to solve this. If you were stuck and you needed to watch the first few steps, that's okay, just to get you started. So I'm going to say, well, equation number 1, I like the way that it's lined up because I have my x's and my y's on one side. Not that that's important, but I'm going to leave that one as is and just write it out as x plus 2y equals 0. And then I'm going to look at my second equation for a second here. And I can see that my y and my x are not going to be aligned if I set them up that way because they're on opposite sides of the equation. So I'm going to move my y over to the opposite side. And so in doing so, I get negative y. So the result here is x minus y equals 3, because remember, of course, that 3 is still staying there all by itself. So now what I want to do is I want to take a look at what I have. I need to see, if possible, if there is an equation that has the same, where one of the variables has the same coefficient. And of course, right away, I notice that the x and the x both have a coefficient of 1. So that will allow me, if I subtract these, it'll allow me to get rid of my x variable, and that's what I want to do. But we need to be careful here. So first off, I know that 1 take away 1x, 1x take away 1x will give me 0x. I'm going to get that in. That's the easy part. So 0x. And now I'm going to keep going, but I need to remember that over here I have a negative sign, so I need to be aware of those negatives. So, of course, the coefficient beside my y here is a 1 as well, even though it's not written, it's understood to be so. So I'm going to go ahead and see this. So I have 2y take away negative y, right? So if I need to, I can do that on the side. Let me just see that. So 2y take away, and that's this takeaway right here, negative 1y. What do I get when I do that? Well, I end up with 2y plus 1y. So as a result, I should get positive 3y. And so keep going. I have 0 take away 3. So 0 take away 3, of course, gives me negative 3. So let's clean this up. 3y, 3y equals negative 3. I'm going to divide out my 3, and that will give me y equals negative 3 divided by 3, or y equals negative 1. And so now what I'm ready to do is I'm ready to go ahead and solve for my second variable. And I'm going to choose equation number 2. And the reason that I'm choosing that is because I can see that the x variable, which is the one I'm looking for, is already isolated. So I know that x is going to be equal to whatever y is plus 3. We just determined that x was -1. So I'm going to sub that in, plus 3. And so x is equal to 2. So therefore, I can say, I'm going to do this in green over here, therefore the solution is 2, -1. So it's not unreasonable for you to have struggled with some of this negative business over here and the negatives and the positives, so don't be discouraged if you did struggle with that. What I'd like you to do is I'm going to assign a couple of questions here for you to try out, and then we'll come back tomorrow and sort of speed up the process a little bit by looking at another example. I'm just going to move some of this out of the way here so that I can assign you guys some homework to try. And I'm going to have a second video posted for you to check out the more complicated elimination questions. Let me get rid of this. So here are some homework questions that I'd like you to try before you watch the second video. I would like you to try on page, page 30 in your textbook. If you take a look at question number 2, I'd like you to do questions A, C, and E. As well as, I'm looking at number 1 as well, number 1, A, C, E. So take a few minutes to work through those problems. I'm going to be posting a second video in some time that you can take a look at. And that will allow you to, before you start the second video and the more complicated questions, you'll have a pretty firm understanding, I think, of these simpler solving